Hello and welcome to our mini project presentation. Our topic is counting machine with infrared sensors. Let's get started. So these are the contents that we will be discussing today, starting off with the project's concept and objective. We will also be discussing the tools required for the project and how the machine actually works. And lastly, we would end the presentation with the demonstration and conclusion of our project. Starting off with our concept, our system utilizing infrared sensors and an Arduino microcontroller accurately counts people in real time as they enter or exit a designated area. It eliminates human error and offers real-time data for efficient resource management. Now, let's talk about the objective. Our primary goal is to develop a reliable and easily deployable solution for tracking the number of individuals in a given space. This is particularly beneficial for 1. Ensuring safety limits in conference room. 2. Monitoring restroom occupancy. 3. Managing crowds at events. By achieving these, we aim to improve safety, optimize space usage, and enhance overall management efficiency. Next up is the tools required for our project, which are 2 sharp infrared sensors, the Arduino Uno board. We would also need a breadboard and wires to connect them to the Arduino Uno. And last but not least, the LED display or the 7 segments. On to how the machine works. The counting machine employs 2 infrared sensors positioned at the entrance of the area. As individuals pass through these sensors, the system detects interruptions in infrared signals and adjusts the count accordingly. One sensor registers entries while the other records exits, ensuring precise tracking of the number of people inside.
This video is sponsored by Cybertize, the website for buying Arduino tools. Thank you, Cybertize! And now for the circuit description. As you can see here, there's 2 sensors connect to Arduino board. For the circuit compromises the following key components: 2 infrared sensors connected to analog pins A1 and A2 of an Arduino board, power supply to the sensors and the Arduino, and serial communication for outputting the count to the monitor. Here's the basic wiring diagram. Connect the VCC and ground of both infrared sensors to the 5V and ground pins of the Arduino respectively. Next, connect the output of the first sensor to analog pin A1, and then connect the output of the second sensor to analog pin A2. And now for the code description. We have used the voice setup for setting the pin A1 and A2, and we have used the while loop for the conditioning. Now let's point out to the each session. First one, we define the analog read of A1 and A2 and make the number of people to 0. And now we set up A1 and A2 as an input at pin mode. Initialization. The sensors are defined and initialized in the setup function. Next one is about the while loop. The main loop function continuously checks the sensor values. Next, the counting logic. If the first sensor in F1 detects an object, the value that more than 300, it increments the people's count. It waits for the second sensor, INF2, to confirm the entry. Last one, debouncing, is about the delay that added to prevent the multiple counts from a single entry. As you can see that I made the serial print and print line about the number of people. It will show in the screen of output. And for the another sensor that INF2, if it detects an object value that more than 300, it will decrease the number of input with -1, and it will have to wait for the first sensors INF1 to confirm the exit. This is the inverse of the first sensor of INF1. And now let me show you about our project demonstration. Let's see the video now. That's it, you have watched our project. Now let me explain each sessions. First is our static start. As you can see in the program, it will say the number of people in toilet, which because I have modified the code at that time, like said about in toilet. Yes, and it will start with 0. But for the future, we can implement the 7-segment or LED display to make this number to show the output on that item. But for this time, we didn't implement it. Now let's talk about when the sensor got the input. As you can see in the video that if the hand go to that direction, that means the input will +1, and this action can be performed many times, like to make the input +1, +1, +1, and goes on. And in the meantime, if you can see that the hand go to the other direction, the inputs will -1. And also, again, you can do it multiple times to make the input increase. And now for the last part, it's about the conclusion. In conclusion, the counting machine with infrared sensor represents a robust and innovative solution for real-time monitoring of human traffic in a variety of settings. Its versatility allows it to be adapted for diverse environments, from managing the flow of people in public rooms to ensuring safety limits in conference rooms and monitoring customer traffic in retail stores. By leveraging the precision and reliability of infrared sensors, combined with the processing power of an Arduino microcontroller, this system provides an accurate count of individuals entering and exiting a designated area. The implementation of this technology can significantly enhance operational efficiency and safety in high-traffic venues such as concerts, sports events, and conventions. It can be instrumental crowd control and emergency evacuation planning. In commercial space, it aids in customer behavior analysis, optimizing staffing levels, and improving service delivery. Moreover, in the context of public health, such as during a pandemic, it ensures compliance with occupancy limits and social distancing guidelines. And about the design simplicity coupled with the ease of installation and scalability makes the counting machine with the infrared sensor an invaluable tool for facilities management. As technology evolves, integrating additional features such as wireless data transmission, remote monitoring, and advanced analytics could further enhance its functionality and application scope. Overall, this project not only demonstrates a practical application of sensor technology and embedded systems, but also underscores the importance of innovative solutions in addressing real-world challenges. Thank you for listening to our presentation.